Okay. Hello, everybody. My name is Antonio Segura Puimedon, and this is Dani Mellado. And we will be giving you a bit the project updates, that whatever we did on the Pike cycle, what we're going to do on the Queen cycle. And I ask you, please, that if you have any question, feel free to interrupt me and ask whatever you want. So Kuryr started as a way of consuming OpenStack networking for containers. Started with Docker, then we went on to supporting Docker Swarm. Then we went and supported also Kubernetes, and that you're going to see mainly Kubernetes because that's our main use case now. Not so many people ask us about Kuryr-Lib network. There's people that use it though. And for example, the Zune project consumes it, and I'm going to talk about one feature that they are working on right now. And also, there's people working on the storage side of it, mostly from the Huawei part of Kuryr. And that team, what it allows you to use is Manila and Cinder shares, which can be quite handy for the volumes. So in terms of contribution this cycle, I counted it with a person day effort from Stacklytics. You can see that it's still Huawei and Red Hat at the top. We saw Mirantis go away from it, but more or less the slack has been picked up by other companies, and also in the amount of committers in Red Hat, the amount of patches increased. So we are able to go faster than ever, so that's good news.
Okay, so one of the things that we have been working on this cycle is basically to support a QADM. So basically, up until so far, we were using Hypercube to deploy Kubernetes within, well, the DSVM and so forth as a method of installation. So we have been switching to QADM. So I guess it should be quite more reliable right now. And also, we have been also creating packages for RDO, which are available on DeLorean. So just in case you want to, get a preview of them, you should be able to find packages for both Kuryr-Kubernetes, Python Tempest Test, which are Tempest tests for the Kuryr-Kubernetes that I'll be speaking later on, and also like Kuryr-Lib network and so on. So one of the more things that we have been working on into is to enable IPv6 support with a caveat. I have to say that, for instance, we need to have only the limitation for Kubernetes. This means that we can only use an /112 as for each
The decider for the network, because they have a limit of 20 bits, and 20 bits feels weird as a delimitation for the subnet in IPv6. So we just cut it usually on 112.
Yeah, we just phone it by a lot of pain.
Yeah.
And also we added Octavia support, which previously we were using just Neutron LBAS version 2, and we have been also adding support for Octavia and Amphoras. And one of the things that we'll be working on also for next cycle is to try to containerize the whole Amphora into a container instead of using as a VM.
Yeah, that would make my life better, because when I'm using DevStack and I include Octavia in it, then it takes forever.
Yeah,
it's like 15 minutes more.
For the upstream gate, it's also a pain though.
Yeah. Yeah, because then you're like multi-node and so on. So one thing, this is the first time we show these results in public, and this is some scale test that we were running. And what we wanted to know is, this is with OpenShift. Even if it's Kuryr-Kubernetes, with OpenShift it works just as well. And we tested quite a bit with it. We're going to add support for that also in DevStack, even though it's not mentioned. So what we wanted to know is like how long it takes to create 900 pods. And the way we did it was just create a deployment and scale the replicas up to 900. And what you can see in the blue line is the time it takes for the Kubernetes API to show the pod as created. And the red line is the time it takes for the API to report it as running, which means that it got the event from the kubelet, well, the update, rather, that it is running. And the interpretation that you can see from this line is that it takes a while for the controller So if you're not familiar with the architecture, basically the controller watches the Kubernetes API and assigns a VIF to each of the pods. And then the CNI watches for that VIF and then plugs it. It uses the same OS VIF plug that Nova uses. So what you can see here, and this is for a nested case where the pods are running inside VMs, so it uses the trunk neutron feature. What you can see is at the beginning it takes a bit to get started, but then it more or less follows the same curve as the Kubernetes API. And where you can see it going up in the end is because of a problem which is like, let's say that this is pooling ports. It means we created about 1,500, 1,600 ports and spread them equally on the deployment. But if the Kubernetes scheduler puts more pods in a node, then you have pooled ports, it will need to create ports. So by the end, we were running out of ports in some node, and it started making a bulk operation. The problem with the bulk operation is that it's very performance expensive in Neutron, which means that even if some other pods were being started in other nodes, Neutron gets a bit slower and makes the rest of the operation slow down. But the good thing is that just with a bit of work, we went from about 4 pods per second in the beginning of the week to 22 pods per second at the end of the week, and we still think that there's a lot of room for improvement with some changes that we're going to talk about later. So, and these changes are, the thing is CNI, how it works, how it's designed in the Kubernetes community is every time that you want to add a pod to your, that you get the pod scheduled, it's just called CNI with add it to the network. So this creates a new process of CNI. And due to our architecture, this CNI process has to connect to Kubernetes API, wait for the VIF to appear there, and then plug it. So with the CNI daemon, what we do is we have a long time running daemon in each node. And in this process, it will constantly be watching the API. So it will only make one connection. And then every time that the executable is called by kubelet, it will only send a request to the daemon, which will already have all the information, or it will wait a bit, and it will give it. So no more HTTPS requests having to go to the Kubernetes API. In the future, we even consider to move the pool to the assignment of the VIF to the daemon, so then it will be instantaneous to start. And for high availability, this is quite important because then even if the controller would go down, you would still be able to get pods created.
Okay, so those are also some of the new features that we have been planning to for Queens. So I guess the first one, because a lot of people are aware of many needs, is compatibility with OpenShift. We are even working on some new plugin to add also OpenShift compatibility with the DevStacks environments. Also, we want to, basically, besides, I'm not going to go over all the things because this is going to take forever, but just I want to mention the two main things, but because we'll be using health endpoints, that basically means that we'll be able to check the health from both Kubernetes and Neutron API from within Kuryr-Kubernetes, and we'll be able to restart the services in case they are not working properly. And I guess that's one of the main features that is coming from Kubernetes, and we are just going to try to leverage it to Neutron too.
Yeah. As more and more OpenStack services go to the step of being run by Kubernetes, we believe that it's more important that all of them add these health endpoints, so that Kubernetes can know if, for example, if Neutron is being run in a container, if it's healthy enough, like if it can talk to Keystone or it can talk to MySQL and so on, and if something like that happens, it can restart, like if something goes wrong. So this is a big feature. This is network policy, and this is the way for Kubernetes clusters to be able to restrict the communication. By default, when you run pods, everything can talk to everything. So the host can talk to the pods, and the pods can talk to the host and to the other pods, even across namespaces. So if you want to restrict it, you can define what's called a network policy. And what it does is it tells you, I only want to allow ingress or egress from these other namespaces or from these siders and so on. And the way we will be doing that is to map it, obviously, to security groups. It will be a bit of a challenge for these operations, because network policy doesn't apply to pods, it applies to labels. So if labels change, obviously the assignment of security groups will also have to change, and the neutron port update operations are expensive enough that we have to think very carefully about how we do this, because otherwise, if you were creating a lot of pods with different network policies, you either would end up creating a lot of different ports for the pools, or you would end up with slower behavior. So we have to see how we manage that trade-off.
Okay, so one of the things that we have been also working on this cycle, and we plan to enhance it quite a bit, it's on creating first a Tempest plugin for Kuryr-Kubernetes, which of course had the challenge to have to integrate the Python Kubernetes client with Tempest itself, as basically all the pods and all the Kubernetes objects were alien for Tempest, so we have to work into that. So one of the next challenges was also the migration to Silver 3, but I guess that's not only specific to Kuryr-Kubernetes, but to every other sub-project. So even if the infra guys have been telling us that it's going to be great, we have been suffering a lot on that. Well, I missed the feedback session, but I'll be being done later on. So we created this a few new gates here. So you could see here, for instance, an Octavia gate, an Elbas V2 gate. Basically, we wanted to add some cross-project scenario test, which would be they have to do with VM and pods. So the first one is that.
So you don't need to go to sleep at 2, like tonight?
No, well, this was working yesterday. Now it's working. So due to my acute jet lag, I was able to fix it this evening, afternoon, morning. I don't care any longer. So. Well, we have a test that is by now just doing pinging in between VMs and pods. And that's the one that we wanted to have as a model for everybody to contribute afterwards.
Yeah, the thing is that it's really important, the cross-project part, so that if something changes on Neutron or in Dragonflow or in OVN or so on, it will not just all blow up. So we have to figure out a way for the gates to publish on several repos or have some kind of agreement, right? But he will be dealing with that. So if you want to do a cross-project, with him for the moment.
I have to admit that we'll be having 2 fancy new team members, so I'll be handing this over. But so far, yes, please contact me.
Yeah.
Okay, so this was also, as I was speaking before about Octavia, so this has been already a feature, but Octavia can, in case you don't know, this is basically a new load balancer for Neutron. So it's some kind of VM with the HA proxy inside. It creates its own tenant, so far you would need a ton of resources on the CI for that. So we have been adding 2 new models of support. So this is the first, layer 3, routed network support, which is a usual use case. But we also do support layer 2 since I don't know how long, maybe 1 month ago or so.
Yeah, okay. Because I think ODL needed it.
Yeah, we needed that for the ODL integration. Things on the fly, and this is a work in progress for most of it, is multi-beef support, because we plan to add also support for multiple CNIs. And that means that we want to be able to connect with multiple Kubernetes clusters at the same time.
Right. Yeah, this is actually being worked on by Samsung, this SROB part, and they have like a working prototype. And we hope to have something soon. The problem is that the Kubernetes community doesn't seem to have a big agreement about how multi-network should be done. And also whether it is reserved for special cases like SROB or DPDK or something. So it's a bit of like, we could do it right now, but we kind of want to wait to do it the same way as the rest of the community.
Yeah, well, we were just about to discuss that on the previous talk, so I'll think about you later.
Yeah. So the load balancer service type is something that is quite useful in case that you want to make your Kubernetes service available externally. So the way that Kubernetes does that is they just use the cloud load balancer. So they have something called the cloud provider, which calls, I don't know if you're using AWS or GCE, so it's using their load balancer APIs to load balance to the different nodes. And then when the communication arrives to the nodes, it's already handled by IP tables and kube proxy and so on. So it goes to the right pod. The way in which we chose to do that, because the way in which we do services is quite different. We just our services are an LBAS-B2 entity, layer 4 one. We only needed to really take what we already had and assign a floating IP to it. So it is a very easy implementation. And as I said, it gives you this ease of just making the service available. There is something that we're working on for the people that don't have so many floating IPs, which is the OpenShift routes. And the OpenShift route is something that is specific for OpenShift, but well, if you are using OpenShift, it's sorry.
So in that regard, we have a spec.
The port forwarding one.
Yeah.
Yes. So the port forwarding one would be another way to address it. The way in which OpenShift addresses it is saying, look, you have this DNS pointing to our router. Let's say in our case it's virtual, but each service, depending on the name, it will use the same IP, but depending on the host name, the layer 7 load balancing will point it to a different service or another, which in normal Kubernetes you can do with ingress controllers. And with port forwarding, it's port address translation. But the advantage of this is that if it's just for HTTP and HTTPS, all the services that you have that are HTTP and HTTPS can share the same port and a name. The only bad thing is that it needs a layer 7 policy in the load balancer, which makes us incompatible with those SDNs that are only supporting layer 4 load balancing, which there are some, but not so many. I hope that, well, with Octavia, all of them work with with layer 7 anyway.
So the favor that I want to ask is, please come and give us feedback.
I reviewed
Yeah, totally.
it. I think I put like 3 comments. Yeah. So this is for libnetwork. As I said, I think Zune is the one that is driving this, that they want to add support for SROB. So, and since they use Kuryr-Libnetwork for providing the Docker networking, they are adding this.
Yeah.
I think in general with Docker, it's easier to add things because it's more like you make a request and so on. But so you can add SROB devices. With Kubernetes, it's more like when you create a pod, that pod is final and you cannot add anything to it. There's ways to work around it, but it's something that's frowned upon.
So, well, I don't care. So those are the goals so far for Rocky, which would be the release video on Queens. Hopefully, well, I don't know if this would be for Vancouver, so it's going to be a long flight anyway for our next presentation. So this is the things that we have been planning so far, but we are open to new requests or new contributors. So for now, we want to work on ingress controllers, a common CLI management tool, because well, we would like to integrate maybe with the OpenStack client and so forth.
Yeah. We have something, like if somebody really wants to check the status of the pools or whatever, we have something, but it's not something that we recommend users to use. It's more for developers to check the status of things.
So, and please don't try to use OpenStack or Kuryr, blah, 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 because it won't work so far at all.
Yeah, the CLI tool is like really specialized. It's a module that you have to actually enable, otherwise it doesn't work.
And well, another new feature that we would be working on is this multi-network custom resource definition, and we want to do a POC, but we'll be updating this maybe for Rocky. Nothing too much for speed.
A lot of it depends on the community, like in the upstream Kubernetes community.
So okay, I've been also planning to do some cross-project work, especially for the SDN gating. As we said before, we want to integrate with. Yes, we are SDN agnostic, so we don't really care whatever Neutron is using, but we do want to check if another SDN breaks us at some point. So far we are working on adding multi-node gates for Dragonflow, ODL, Oven. Then just a few minutes after, there was a guy from OpenControl also pinging me that also we might be working on OpenControl too. As we said before, Neutron bulk creations is expensive operation so far, so we also want to enhance that. So thanks, Miguel, for your comments before. Well, we were working also on the Tempest plugin. This is up and running. Its functionality is pretty basic by now. So we just added a few tests basically for the self plugin testing and the scenario manager, which is based on the Tempest Network 1 plus all the operations that we would need so far from the Python Kubernetes client. And as I said before too, like we would like for Octavia to not spawn a VM, but a Kubernetes pod. And this is something that we were starting to draft with the Octavia community at the PTG, and we will try to continue on that.
That's a bit of a big challenge because of the way how the amphoras work, but let's see if we can bring it to completion.
Well, yes, if you want to give us feedback, you say, no, you might want to say that we suck a lot. Also, feel free to do so. You can request a feature, put out a blueprint. If something's broken, please do put a bug. We are also holding weekly RSA meetings as every OpenStack project at 12 UTC, which we know that it's pretty European for now, but if we increase our contributors from the US, we promise that we'd like to do a bi-weekly meeting, one US, one EMEA.
We used to have it in the past, it's just that when US people, mostly IBM people disappeared from the face of the earth, we ended up just shifting to the European one only.
And of course, we do have an IRC channel. You can find us at OpenStack-Kuryr or on the mailing list.
So yeah, I think the important thing to take away is that you can stop us now, like outside, or you can meet us on IRC. And if you want to contribute, or you have a project that we use, in this case Neutron, for example, and you're wondering, so do you know how Neutron behaves under this certain load that you use, or something, like contact us, we will try it, or we'll figure out if we can maybe make it as a cross-project gate test. And if you have any requirement or any feature that there is in Kubernetes that you think maybe it's not covered yet, like that's the kind of information that we need a lot. So even if you cannot code, or maybe you just find the documentation sucks, we're trying to improve. It improved a lot in Pike. We didn't mention it because documentation is the big
even for
forgotten
testing
thing, right? But it improved a lot.
And also,
so
if you treat us to
check.
some beer, we promise that we'll give you preference access to your request. So I guess if you have any question,
right.
That's the time. Or otherwise, we can just go have lunch.
Yeah, you can catch us outside, or you can go and have dinner, lunch with us.
Yep.
Yeah, for the front-end router, so is it directly for the routing, or is it also for the east-west traffic?
So this depends a lot on what you want. So now we're working on the OpenShift Ansible deployer so that it deploys from packages and so on. And just due to however we felt like when we were doing it, the way we did it is like the pod subnet and the pods and the services are in different subnets. That is not necessary though. You could have all on the same subnet, so you would avoid going to the router. But just how we deploy in DevStack and so on, we have it all go through the router for east-west. But we had some people on the IRC that were requesting, hey, we would like to avoid the cost of that, because depending on the SDN, that can be expensive. And they tried to do it all in the same subnet, and it just worked. So it's really up to deployment. It's up to taste.
So if there are multiple Octavia amps, so they all need to connect to the interface of the router?
So, well, if you use the layer 2 mode, for each subnet that you have pods on, it will be creating ports, and that you have to account for when you will be sizing your pod subnet, because obviously it will be taking one port per each LB that you're using per each service, and that can get old pretty fast, and that's why we prefer the routed mode. It's a trade-off. Whatever your SDN behaves better with is what you should be choosing. So we give freedom in that. But we're aware of that with some, going through the router may mean going to another machine, and that sucks. Which part, sorry?
Sorry?
Top end. I cannot. Load balancer.
Oh, okay.
Okay, sorry, I'm a bit.
I didn't understand that either.
This part, yes.
Next year, because you for the part, the part does replication. So what happened?
Sorry, when what goes?
The part is here and replicates the new one. How to make it? The low band bind to the real one.
So that means the question is, if pod is killed.
Yeah, right.
There's a new pod that's created dynamically. How does it?
Right. Yeah. So we have a handler for the events of endpoints. So when a pod is killed and a new one is created,
Yeah, right.
that's an event in Kubernetes that we see, and what we do is we go to the Octavia or the neutral bus v2, depends if you use the legacy connection, and we just change the members. Of course, the members also can have the health monitor, so it will send it to the healthy one, but while the update is ongoing.
So it is automatically to add member.
Yeah.
Yeah.
It is scaling.
From neutral to this one, because you use Robin's ASB2, right? So how does it know you have a new members?
Because we have new pod. The pod hasn't.
Yeah, but part is the
We are just we have a handler that get that information from Kubernetes.
Yeah. So that was one of the first things that we tested when we added the support for.
notify you.
Yeah, Kuryr.
Oh yeah. Oh, they're right.
Right.
They will notify you. Oh.
Exactly. So
Thank you.
we see that and we modify. This is actually one of the most bothering parts of the service handler, like the service, like to watch the endpoints and see how they are increasing and decreasing because of how Kubernetes communicates it. That it just gives you the whole list, so you have to figure out like which were there, which are not. But it's how it is. We hope to make it faster even, but it works.
Okay. Thank you very much.
Any more questions?
Okay, then
Do you have a
thanks for.
question?
Is there any more question? Yeah.
All right. So thanks a
Thanks for
lot.
attending.